Hello, seventh graders. Happy Tuesday. Today we are looking at triangles. It is the polygon with three sides. So we are looking at chapter 9, lesson 8. In your textbook, you should be on page 254 and 255. Mine is right over here. I'm following directly along with it, but I want you guys to be able to see my notes. At home, your setup should have your hardcover book open. You should have your computer and maybe your notebook ready to go. All right, so we're looking at triangles. 9-8. Triangles can be classified in three ways. Our first way that triangles can be classified are by the measures of their angles. So, an acute triangle has three acute angles. It's all coming back, it's all coming back to me now. I know what acute means. Acute means that an angle is less than 90 degrees. Look at that. 1, 2, 3. Three angles. All three are less than 90 degrees. An obtuse triangle, don't worry, I won't sing it's all coming back more than like 5 more times in this episode. All right, obtuse triangle has one obtuse angle. I know what obtuse is. It's all coming back. An obtuse angle is greater than 90 right there. And you have one of them. There's no way you could have a triangle with three obtuse ones, only three acute angles. All right? And last but not least, right triangle. Well, I know what right means. A right angle is equal to 90, and right there, a right triangle has one 90 degree. Triangles can be classified in three ways. That was our first way. Our second way is they can be classified by the lengths of their sides. So an equilateral triangle, equal meaning equal lateral, all of the sides are equal. All of the sides are congruent. Oh, I know that word. Okay. Isosceles triangle means two sides are equal. These two are equal, this one is not. These two are congruent, this one is not. And then lastly, a scalene triangle. A scalene triangle has no sides congruent. So this side is not equal to this side, which is not equal to that side. Okay? Triangles can be classified in three ways. 1, by the measures of their angles. 2, by the lengths of their sides. 3, put them together. Triangles can be classified in three ways. Here is our third way. By both the lengths of the sides and by the angle measures. Acute, that means all the angles are acute. Okay, so here's my acute angles. Scalene, what does scalene mean? Let me pop back. No sides are equal. So that means that this side does not equal that side, which doesn't equal that side. An acute scalene, right? All the angles are acute, none of the sides are equal. Second, an obtuse. Oh, I know what that means. One of the angles is obtuse. Isosceles, let's flip back. Isosceles means two sides are equal. So let's look. Oh, this side and this side are equal. Oh, well, I'm going to mark it with 3. I meant to mark it with 2, but I got distracted by the window. Okay, last but not least, a right scalene triangle. Well, I know that a right triangle has a right angle, and scalene, let's pop back and look. Scalene has no sides that are congruent, no sides that are equal. So this side does not equal this side, which does not equal that side. There we go. Okay, so triangles can be classified in three ways. Let's go over them. 1, by the measures of their angles. Acute triangle, obtuse triangle, and right triangle. Okay. Second, by the length of their sides. Equilateral triangle, all the sides are the same. Isosceles triangle, two sides are the same. Scalene triangle, no sides are the same. And lastly, by both the lengths of their sides and the angle measures. So an acute scalene, all the angles are acute and none of the sides match. Obtuse isosceles, one of the angles is obtuse and two sides are the same. One does not, or does not match. I'm not re-recording. Okay, last one, the right scalene triangle. So there's a right angle and none of the sides are equal. All right, so that covers page 254. Let me just read you the key concept. Triangles can be classified by the lengths of their sides, by the measures of their angles and by both the lengths of their sides and the measures of their angle. Check, we covered that right here. All right, next, I am on the top of 255, okay? 255, I'm looking at the triangle inequality theorem. All right, so I'm going to read this through to you, and then I'm going to talk you through it, okay? So don't fall asleep while I'm reading. The triangle inequality theorem states that the length of the third side of a triangle is always less than the sum of the lengths of the other two sides greater than their difference. Oh my gosh, what does that even mean? Okay, so here's what I have for you. I've got it broken down. I'm going to slide this up for a second. Okay, can we still see the bottom? There we go. All right, what they're saying is, if this is our triangle, A and B is going to be greater than C, but A minus B is got to be less than C. So the third side of the triangle must be less than the sum of the other two sides. So A and B is greater than C. C is less than that, but greater than the difference when they're subtracted of the other side. So let me show you. I'm going to give you A, B, and C. Let me slide it in. Sorry. Sometimes I forget I'm on camera. All right. So say this is C. It is my longest side. All right. It's my cute little Michigan State Lucky pencil. All right. And this table is not straight. And here is B. And this is A. Okay. A, B, C. So what they're saying is, if I make a triangle out of A, B, and C, there's my triangle. If I add these two together, all right, I put them right next to each other, I'm adding them together. It needs to be greater than C. A plus B needs to be greater than C. Now, if I did A minus B, and I took B away, this is what I have left. This needs to be smaller than C. C needs to be greater than this. That is what the triangle inequality theorem is telling me. Okay, so I'm going to take a picture of this little formula in my mind. Don't worry, we'll help you through it. We'll walk you through it. All right, and let's look at the bottom right here. Actually, let's look at the example first. Okay, so I'm going to keep this triangle inequality theorem up, and we're just going to overlap like that a little bit. Okay, so for example 1, not number 1, sorry, my markers are rolling. For the triangle X, Y, Z. All right, so I'm at example 1, not at the bottom. Example 1. For triangle X, Y, Z. All right, well, I'm going to draw it out. I'm a visual learner, so here's my triangle. I don't even know if that's right, but they said, okay, so here's X, Y, Z. XY is 3. Okay, so we all see that. Here's my XY. It's equal to 3. All right. YZ is equal to 4. What are the possible lengths for ZX? Okay, so YZ is equal to 4. They want to know what are the possible lengths of ZX. Okay. Well, if I am following this, A plus B, well, here's A, 3 plus 4. A plus B is greater than C, but C is greater than A minus B, okay? So is greater than, I'm going to leave this blank, A minus B. Now, what are those lines right there? Absolute value lines. So that means whatever I subtract here, whatever I fill in for A and B, it's going to be a positive number because it's the distance from 0. So 3 minus 4, which is -1. Absolute value is 1. So what they're saying is C can be less than 7 and greater than 1. So what are the numbers that C could equal? C could equal 6, 5, 4, 3, and 2. All right. Now, let's look at try these, okay? How many triangles are in the figure? So let me pull this out so I can see it. All right, now I am going to break the biggest rule in school, and I'm going to use color in my book. Please don't do this at home. All right, so if I am looking, and I could say that these little things are triangles, but I'm not going to because I'm looking for the letters, okay? So I'm looking at A, C, F. There's one triangle. I'm looking at, let me make sure you guys can see me in the book. Yep, okay. C, F, E. There's another triangle. Looking at B, A, C. How about C, D, E? What am I at? 4. A, G, E. Okay. So then, looking at A, D, C. So 1, 2, 3, 4, 5, 6, 7. Am I missing any? I'm thinking I'm looking at 7 triangles in the figure. Come to Zoom and let me know if you see anything different. I went from letter to letter though, so that was my main thing. Yeah, I think I'm good. Okay, number 2. How many equilateral triangles? Okay, well, let me go back. What is an equilateral triangle? Let me put this back. All sides are equal. All right, so we're back to the book. And we are looking. How many are equilateral triangles? So, those lines tell me that they are all, so A, B, no, all of the lines are equal. I would say, and let me just show you. Remember, don't do this. Right there is my equilateral triangle. All the sides are equal. So AC, CE, EA. That is an equilateral triangle. Everything else are either isosceles, where they have 2 sides that are equal, or scalene, and no sides that are equal. All right. Yeah, we touched on all of those. Okay. All right. How many are obtuse isosceles triangles? Okay, let's go back, review what does that mean. That's what we are going to have to do. Obtuse isosceles triangles. 2 are the same with an obtuse angle. All right, let's go back. Obtuse isosceles. I'm going in with blue. Okay. Well, right here, those 2 sides are the same. There's an obtuse angle right there. So there's 1. Obtuse. Those 2 sides are the same. There's 2. Those 2 sides are the same. And that's an obtuse angle. There's 3. And remember, 2 sides have to be, I would say there's 3. Right? Because 2 sides have to be the same. So even though this is an obtuse angle on this triangle right here, that side doesn't equal that side, and that doesn't equal that side. That's an obtuse scalene. Okay. Can the set of given measurements be used to form a triangle? Remember, we've got to follow the rules. So I'm going to get my notes out. I'm going to use pen because I think it's fun, and, you know, we're in quarantine. I need a little something to brighten my day. Okay, so remember, the formula is A plus B is going to be greater than C, and C is going to be greater than the absolute value of A minus B. Whoa, I'm getting a new accent here. Okay, so C is always going to be our biggest one, our longest side. That's just something that goes with triangles. A squared plus B squared equals C squared, all of those things. So A is 2, B is 6. And what we're trying to figure out is, does 2 plus 6, is it greater than 9? 8 is greater than 9. Is that a true statement? No. So, write yes or no. No. How do I justify my answer? Right there. That doesn't work. That's it. Number 5, switching colors to make my soul happy. Number 5. Okay, same formula. I'm not going to rewrite it because I've got it right up there, even though I usually do. Wow, I have gone rogue. All right, 4.5. Now look, that longest one is 7. So I'm not putting that as B. I'm putting 4.5 plus 3.2. Do not let them trick you. Some guy is sitting in his office who's writing this book going, I'm going to trick those 7th graders. So, pulling out my calculator. No, I can do this. 4.5. Well, 5 plus 2 is 7, so it's 0.7. Oh, 7.7. And we're saying 7.7 is greater than 7. Did I pass my first check mark? Yes. Now we're saying is greater than 4.5 minus 3.2. Okay, absolute value. All right, so you can use your calculator. I think I can do this one in my head too. 5 minus 2 is 0.3. 4 minus 3 is 1. Is 7 greater than 1.3? Yes. So this one works. How do I justify my answer? Right there. I just did my work. That's it. Isn't that so nice? That's why you show your work always and forever. Number 6. A plus B. Okay, we're looking 1, 2, 3. Okay, so 5 plus 12. That's 17. My math is much better today than yesterday. Is greater than 13. 13 became C because it's the biggest value. All right, so 17 is greater than 13, passes the first checkpoint. Now 13 is greater than the absolute value of, 5 minus 12, which is going to be 7, but if you need to, 5 minus 12, it's always good to check myself. 5 minus 12, negative 7, but the absolute value makes it 7. So what they're saying is 17 is greater than 13, which is greater than 7. Does that work? Yes. How do I justify? I just did. Showed my work right there. Okay. Hopefully you guys can see all of that. Great. Okay, so we're looking at number 7, 8, 9, and 10. True or false. Okay, let's use my notes to help us justify the answers. Number 7. Every acute triangle has 3 acute angles. So let's go back. Every acute triangle, that's the triangle. Every acute triangle, here we go. Every acute triangle has 3 acute angles. True or false? True. Next one. All scalene triangles, let's go to, well, my book is falling over. All scalene triangles. Oh, did you guys not, were you not able to see my acute? Oh, no, you were. Okay. All scalene triangles are obtuse triangles. Well, this proves it wrong. Right scalene triangle tells me that I can have 3 sides that are not the same length, but it doesn't need to be obtuse. And that's an acute angle, and that's an acute angle, and I can just see that with my eyes. So, number 8 is false. Number 9, all isosceles triangles are right triangles. Well, I'm going to prove it wrong right here. Obtuse isosceles triangle. So not all, that would be false. Some are, but not all of them. And they could be. That could be a right, or that could be a right angle, and those two could be the same, but not all. So that one would be false. Okay. So today for your homework is 9-8. All of it. All right. I'm going to give you another homework help video. If you're grooving and you're feeling good, great. If you run into some trouble, take a peek at that video. And what's nice about it is you can like scroll through. If you're like, I don't need your help with 1 through 6, scroll through. All right. Hey, good luck 7th grade. I'll talk to you later at Zoom. Whoa, sorry for that.